Well, thanks for coming in today, people. So I'm Paul Gavini. I've been teacher for 24 years now, doing this physics stuff, trying to get you through, all my students through with a nice high score as best we can. So I'm going to go through a few things today that will hopefully make an impact on not only physics but the other subjects as well. Bit of housekeeping, toilets. So if you need to go to the toilet, out there, head all the way down, turn left again, it'll start to look a little bit creepy and dark. Then you'll see a whole pile of rubbish, pallets, turn left again, and then you've got the toilet sitting in there. There's a few signs, okay? Mobile phones, can you chuck them on Do Not Disturb? And question time. At the end, I'm going to hang around, so if you do have any individual questions that you don't want to discuss in a public forum, you can come down and have a chat with me, okay? So today we're going to go through the course, look at preparation techniques, exam techniques, and I'm going to go through the 2020 exam and actually look at the Chief Assessor's report, because that's a publicly available document, more or less that tells you exactly where all the students made mistakes last year. I'm going to go through some SHE questions, hints, and then general questions at the end. All right, so with the topics that you've been doing so far, you've got the three topics: motion, relativity, topic 2, electricity and magnetism, and last one, lights and atoms, which hopefully that you're finishing up with at the moment. Assessment, okay, so your exam is worth about 3 tests, so we definitely want to prepare for that one. You've got your SATs, skills and assessment tasks, so they're the tests that you've been doing, and your investigation folio, so your design prac, investigative prac, and also your SHE. D-Day this year is the 11th of November, pronounce it better, okay. 9 o'clock, 130 minutes. Please don't do what one of my students did one year, turn up exactly on time on the wrong day, okay. There is no exemptions for that, you just lose your 30%, okay. Lots of cheers were actually shed that day. Okay, so preparing for the exam. I'm just going to hop out here. So believe it or not, this is the revision guide from 1990. Okay, so this is my Year 12 SASTA revision guide, and I've just brought it in just to highlight how the revision guide that you have now has a large amount of strategies in there. So back in my day, okay, so you had the contents, terminology used, a few words, and then straight into the practice questions, etc. With yours, you've actually got checklists, okay, descriptions, you've got key calculations, derivations, you've got all these information there. So after today, definitely want you guys to go away and reread your revision guide, okay? Anyone not have one of these? All right, if you don't, you can pick up last year's as well. If you know somebody, maybe the school's got some in the library, please borrow it, read through that front content section again. Okay, so what you need to have is a good ideal study environment. So if you've got a noisy place, you've got other people talking around you, not a good place to study. You need to be in the zone, and it needs to be part of your routine. If you don't have anything at home or an area that you can actually use, then stay a little bit longer at school, hang out in the library, get it done there, okay? So you really need to get into that routine. A lot of schools will say, when it comes to the SWAT vac, you know, I think after week 2, you can be kicked out and then you can go home and study. But if home study is not favourable for you, I've got one student who's got 4 other siblings, younger, okay, he actually still comes in. Okay, even though he's got free lessons, he can go home because he can't get anything done because they're all raising a ruckus or crying and mum and dad are asking him to do jobs around the place. Okay, so even after you go into that swap back, please speak to some of your teachers and say, hey, I need to study, can I just grab a quiet place in the back of the library or in the back of the classroom? I doubt there will be any complaints if you do that. You need to identify your needs and you need to take it seriously. Again, it's worth 3 tests. If you think about the effort that you made just to pass 1 test this year, times it by 3. And you need to summarise your knowledge. Do some writing. There's actually a lot of recent psychological analysis on brain function and hand-eye coordination in actually long-term memories. So handwriting your notes is about 20 to 25 more effective than actually typing them. Okay, so that was an article that came out in New Scientist last year. Also recite it and have a go at making up some questions. But if you're not good at those, you've got a whole revision guide with lots of questions that you can practice. We all okay with that? And some of you are already going, yes, that's what I've been doing. So excellent if you have been. All right, so the first thing you need to do is take a stock take of your skills. So that's going to be found on page 7 and 8 of your revision guide. If you don't want to take notes as you're going, I'll put up my email address and I can actually send you today's PowerPoint if you like, okay? I'll do that at the end. And you need to do a stock take and you need to be honest, all right? So if you're crap in one particular area, admit that you're crap, all right? Tick it off. I need to focus. I've got projectile motion under control. I'm not going to put a hell of a lot of revision into that one. What have I done? That's better. Okay. This one is very important. Have you made a timetable yet? Hands up. Who's made a revision timetable? 1, 2, 3, 4, 5. Excellent. All right. When those people who haven't made a revision timetable, do it. Plan it. Okay? I'm going to study this. And don't say I'm going to do a study session on, it's a bit of chemistry or a bit of physics for 2 hours. Your brain will be fried and it's actually the neuroplasticity and your ability to retain that information is going to decrease dramatically after about 45 minutes. So doing massive study sessions on one particular thing is actually worst practice. All right? So I would say maximum do 1 hour blocks. Okay? Take a 15-minute break and then continue on with something different. Okay? And if you want to do physics for the whole session, do one aspect, then do something totally different. So you might want to go and do, the standard model after doing some 2-dimensional motion. 2 very contrasting. Yes, you can get away with that one. Flashcards are beautiful. Okay? However, this day and age, a lot of people don't do them. Who does flashcards in here? Oh, okay. Every time I presented this to my students, they go, oh, how dorky is that? All right, so you don't have to do that, but they are super duper effective. I'll just do a quick little demo of an alternative strategy. Okay? So just for today, I'm just going to crank up my mobile phone. You guys can see that? Let's go down a bit more. So all I did on my phone was actually take some pictures. All right? And I'm going to go through these questions. This took me literally 5 minutes to do. So I've got one photo there. Okay, so I'm going to spend some time, whether I'm sitting in the car, you know, maybe I'm at lunchtime, all right, or I want to pretend that I'm on Tinder, so I'll just swipe right, okay, and then I'll get the other, then I'll look at that question there. Don't like my phone at the moment. Here's another question. I'll just go through those with the solutions, all right? For derivations, okay, all I did quickly here was actually record myself with my phone, so I wrote it out while I'm holding my phone. So I wrote it out and then I just watched the little 30-second video that I just made to go through how to go through those derivations that you need to learn off by heart, okay? So if you don't want to do flashcards, take photos of your handwritten work and upload them to your camera and slide them through, all right? What have we got here? Beautiful. All right, sticky notes. This has actually been proven to work as well. It's a little bit weird. I even got my daughter when she was about 11. She was trying to learn French. So yellow sticky notes all over the room and also in the house. Labelled it, okay? So every time you look at, oh, I'm going to get the sock drawer open, okay? You actually see some sort of physics there, all right? You go to brush your hair in the mirror, there's another note there, okay? It is a very highly effective mechanism. It's weird, okay, but it's highly effective. Concept maps have actually shown. So this is mine here for electric forces, actually spreading it out, summarising about 3 weeks of work on an A4 sheet of paper. Some of you may have done some concept maps as part of your deconstruction in your design. 20 to 30% extra memory recall and understanding if you do those flow diagrams, concept maps, mind maps, whatever you want to call them. Okay? Draw little pictures. Okay? Summarise your information. And I guarantee you, if you can't make the links like I've got there with the arrows, then that actually tells you you don't understand it fully. You don't understand the relationships. So have a go at making some mind maps. That will definitely enhance what you do. Okay? That's what I'm looking for. Cool. In your revision guide, there is already a strategy and a timeline of what you should be practicing. Okay? It's the same with the chemistry, psychology, biology 1, etc. So, week 2, term 3. So, you should have a go at those questions there. Okay? Week 3, term 3. So, at the moment, what have we got? Week 7 is just finished. You should have done motion in electric fields and practice those questions. Did anyone do those? One person has. You've actually read it. Yay, okay. So again, that's going to help you break it down. A little bit from here and a little bit from there, a little bit from there, so you don't get saturated in one particular area. You're doing all over the place. All right? It's going to increase the probability of recall. Follow the plan, stick to a schedule, okay? So important to stick to a schedule, all right? Because things happen, okay? And you need to make excuses about why you're not going to go with that commitment, all right? Oh, just hop onto Twitch or something, do some live streaming, watch this, okay? Oh, look at this wonderful clip on YouTube. Schedule some time where you have entertainment. Everything else gets blocked out. After your exam, woohoo, go crazy, all right? But in the meantime, devote yourself. And if you've got a part-time job, technically, that is your break. Okay, you're doing something else. I actually, before my Year 12 physics exam in 1991, I was actually working to 2 o'clock in the morning. Something I don't recommend you guys do, okay? However, you got to balance work, study, etc. All right? And relationships, put them on pause, okay? Because they just mess with your head too much. All right. use multiple techniques: visual, audio, summary notes, okay? If you actually do a reading out of the book, okay, record it. On the bus, push play, listen to yourself talking about those little notes. All right? It doesn't cost you anything, and it's a better use of your mobile phone. Mindfulness. Those people who came in early, you notice that background music? Yep, okay, so that's from the Chilled Cow lo-fi. That's the one I listen to. I've got some mental year 8s at the moment in my science class. I put that on in the study time, and it's like music calms the savage beast, okay? It's actually been shown, if you listen to music that has lyrics in it, your subconscious is actually focusing on those words, and you actually can't study as effectively. Your brain processing is actually reduced, all right? So if you're going to listen to some music, no singing vocals or anything, okay? That's the most effective one. Get off of social media, music, no lyrics, and exercise, okay? Probably about in 2017, I had a physics student who went on and actually got a merit. His hair started falling out, okay? Mindfulness is very, very important. And he was stressing all the time, and it got out of control. Even on the smallest things, he started stressing. Exercise. Exercise is better than any antidepressant medication you can get. Ask any doctor. So if you want to take a break and you're stressing, go walk the dog. Go for a jog, go for a walk. If you've got a treadmill at home, hop on that. That's the only way you're actually going to get good stress relief, right? And not caffeine, right? Caffeine is actually banned by Air Force pilots. Did you guys know that? So if they actually take a Red Bull to be energized, so they're more alert, they're actually banned from flying for over about 2 to 3 hours, because caffeine has been shown to increase your error rates. So you make more mistakes when you're on caffeine, okay? So you definitely don't want to be dependent on that. Practice does not make perfect. I had a student once, studied, showed me about 5 to 6 pages of notes, absolutely failed the test because she only practiced the stuff that she knew. She actually wrote all the notes out from memory. What's the point of that? Okay? You need to be focusing on your weaknesses to get stronger. So, make sure practice does not make perfect. What you need to be doing is looking for patterns. All right? I could actually go through that 1990 SASTA revision guide and actually find questions in there that you're going to have in your exam this year. There are patterns. There are general questions that actually get asked on a cycle. That's why my students have got the last 20 years of exam papers, so they can actually look at all the different types of question styles. Ask any merit student. They memorise the question styles. Go to these holiday workshops. They will take you through, for about $300 or $400, they will take you through all the different types of question styles. So when you actually sit the exam, you already know how to answer that particular question. All right? Also, make your responses concise. You're not doing English, okay? There's no word count. Make it concise. And the biggest one is make sure you use physics terms. Do not use generic terms, okay? Pull out the big wanky words, okay? You know, you got to do it. Also, speed in response. You've only got 2 hours, and please do not practice stuff that you already know. In your revision guides, you got key, descriptive, and explanatory concepts. Okay, having a dyslexic attack right now. Okay, so those in your revision guide, it's already been summarised, all the key points, the key concepts that you should know. Okay, have a read of those. Terminology. So when you get your physics question on the day, there's going to be keywords. State, write the answer to the question concisely without reasons. So you just state it. Don't think about it. That's usually about 1 mark. Describe, okay? I'll let you read that one. Again, this is actually summarised in your workbook. So when it says describe, don't state it. Explain or justify your answer. And the key one there is actually identify the relative physics concepts. One of the questions we're going to go through is, why do rockets go up? Can someone tell me why rockets go up? Show of hands. It's a year 11 question. Sorry. Come on, guys. Bit of energy. Okay. Rockets go up because what's going out the back? Come on, gentleman with his mask down. What's going out the back of a rocket? Sorry? No? Exhaust gases. All right? So one's going that way, so the rocket goes the other way. Which one of Newton's laws is that one? 3 to choose from. 33% chance of getting it right. Who votes first? Oh, hang on. What did you give me then? Okay, I thought you gave me that one. No, okay, right. I'm joking, okay? All right, so Newton's third law. That would be the link to the physics concept. Yeah, rockets go this way because it was exhausters going that way. Why? Newton's third law. So that's the little bit that you need to add in, okay? Have you signed in? Okay, go up to the top there. All right. Discuss, all right? So commonly in physics, meant to describe and explain, okay? May also get you to discuss alternative points of view, especially if it's part of a written response. Calculate. Show the steps. Who uses graphing calculators in here? Right. Leave them for maths. Okay? Do not use the graphing functions. Just use it as a scientific calculator. Right? Because there were so many students who lost marks last year because they actually used the graphing solver to do things. No, you're going to get penalised. Determine. Okay? Which means you're going to have to rearrange something. Also linked with doing a proof. Show in the calculation. Right? So that means you need to write out the equation, substitute, do your rearrangement, and don't forget about sig figures. Verify. So normally when you get an easy one, oh, the answer is this. Can you show the working out to prove that? I like those ones because you know when you're stuffed up. Hence, okay, so that means you need to look at information from the other aspects of the question. Derive, okay, that's when you start pulling out your math skills. All right. Please don't think on the day, just because you've got an equation sheet, that you're going to be okay. All right. It's not like maths where you walk in with a cheat sheet. Make sure you've actually practiced the derivations, okay? Going back over examples, all right? Because when you're doing your exam, you're going to be under stress. There's no joke about that. And when you're under stress, your memory fails you. That's common for everyone in the world, okay? So make sure you look at rearrangements and you've got the skills with those particular questions. All right, describe an experiment. Always substitute in the diagram if you can. The diagram must have labels. No labels, no marks. Otherwise it's just a pretty picture. Determining a ratio. Believe it or not, it's amazing how many students can't do that on the day. All right, playing around with fractions. Make sure you got ratios under control. Very important when you're looking at electromagnetic induction, when you're doing the solenoids. A lot of students will say, 2 to 5 ratio, but then they actually put it 5/2. They get them all flipped over. All right. That's an atrocious graph in the right-hand corner there. It's off the axes. Make sure it's got a title. You've actually labelled the axes. You've actually put the units on it. Okay? There wasn't much graphing last year, so I'm guessing there's going to be a significant graphing question in this year. And there wasn't one much in 2019. Yes, physics teachers sometimes gamble about what questions are going to be in the exam, do some predictions. All right, make sure you do it and you make sure you stay on the scale. And the other one is make sure it's big enough, please. If it's a small one, moderators, they just won't even try. And half of them are geriatrics over the age of 60 and they got bad eyesight. When they're actually marking your work, you'll be lucky if they spend 60 seconds on that page. All right? They don't have the time when they get their bundle of 50 exam papers to mark in 2 nights, okay, after they've been teaching and working at work all day. They're not going to really have the time to hunt around and, has the student demonstrated and everything else. They want to see nice, clear, concise answers, right? They will not have the time to go, oh, did they really explore that and, let's check all this. No, it's got to look good. All right, plotting and drawing, okay. Do not use a crayon, okay. Make sure you got a sharp pencil. Make sure you use a ruler. If you do forget the ruler on the day, get an A4 piece of paper, fold it about 3 times on top of each other, and then you end up with a nice straight edge. And a lot of students do this one. When you do your graph, okay, you need to know the difference between direct proportionality and linear ones. Direct proportionality goes through the origin. If it's proportional, that means it's not going to go through the origin. There's probably a systematic error. That is like a common mistake. Students do it every year, all right? Don't automatically draw something through 0, 0, especially if you're describing a relationship. And one of the questions that we'll go through later on highlights that. Okay, so make sure you look at your graphs properly. All right, page 12 and 15. You've actually got your derivations, practice them. That's the only way you're going to learn them, okay? You can't look at it, you need to practice writing them out maybe 10 or 20 times so you know them off by heart. All right. We're going to start with last year's exam paper. So I'm just going to have a drink. Did anyone have any questions so far in terms of the strategies? All good? All right. Every year, this is the first question in your exam paper, except for 2 years. It started off as something weird. All right, so we've got somebody chucking a ball using a third order lever. They'll actually put it in a context to actually show that it's socially relevant. So you need to do some trigonometry. Every year students mess up sine and cos. So please, just on the side of your exam paper, actually draw the triangle. Okay? Just put it there automatically. A lot of students will just accidentally mess up the vertical and horizontal velocities. I see it every year. Okay? I'm just going to do this. Alright. Cool. No. Cool. Alright, so make sure you put in the equation. So put in your equation, substitute your values, then chuck out an answer. Show that the projectile reached its maximum height after 1 second. So these comments that I put on the side with the unhappy face are actually from the Chief Assessor's report. Alright. You can find them on the SACE board website. So it's a free document for everybody. So this tells every teacher and student who reads it what people were successful were and what students did that were unsuccessful. All right, so if you want to do some late night reading, please go through that one. All right, learn from other people's mistakes. Bang, bang. All right. So show the projectile had reached this maximum height after 1.06 seconds. So again, write out the equation, rearrange it, substitute your values, chuck out the answer. All right. So a lot of students actually chuck that one through the graphing calculator. With this one here, calculate the maximum height above the ground, because the person was already 2 meters 10, including the actual stick. A lot of students have worked out what the height is. All right. Now, it's always good to avoid, so you've worked out the time there, rather than using S equals V naught T plus half AT squared, try and use a different equation that doesn't rely on the answer from the previous one. Otherwise, you're going to, so let's say if you make an error here, then it's going to carry over into here. If you can, use a different equation that does not rely on that first value. Most of the time in your exam questions, that will be the case. And don't forget to add the extra height. Students always forget to add that extra height. All right? So you're launching it from a height. All good? Oh, yes? Yes? So if you do stuff up part 1 and you do carry over that area into part 2, yes, but as best practice, don't rely on the first one. Okay? You don't want to be doing that, and then the exam marker has to spend time trying to go through all of that, and they just might go, I'll just take off a mark anyway. All right? Rather than don't risk it, go this way. All right? And don't forget about your sig figures. All right? So you will get penalised for that. Remember, you can only be as precise as your least precise number. All right. Again, these are the answers because you've got the exam answers in your revision guide for last year's. So I actually went through this, copied down those answers, and then I put in a bit more extra detail. Okay? Which is a strategy that you guys can do as well. Pick up the 2019 exam paper, and if you're not in the mood to think about it, okay, maybe go and print off the 29 exam paper. I believe it's still on the SACE board website, and actually practice writing it in the answers. Okay, it doesn't involve much thought process. It's not really an excellent strategy, but it just forces you to actually write it and use the terminology, and hopefully you'll remember something that you actually wrote down as part of your visual recall. Alright, this one here, why is the maximum height affected? Due to air resistance. Most of the students that stuffed up this question just did not use physics terms. Okay? Don't use generic terms. Alright, that's okay for year 10, not for year 12. So air resistance, drag force, downwards indicating a direction. Okay? So make sure you use those terms. Alright, question number 2, satellites. Students always hate doing the satellite questions. There's so many places where you can stuff up. And the 90% of the time where you stuff up is actually using the calculator. Alright? Please use brackets when you type it into your calculator. So the numerators, put that in bracket, divide by the numbers, put them in bracket as well, alright, and then put brackets around the whole lot, put the square root symbol. Use them when you type them into your calculator. Alright, it will save a lot of tears and wrong answers. When my students do their work, every time there's a calculator error, I show them how I type it in, gets the perfect answer straight away. Alright, most of the time these ones always is the calculator. For this one here, students got the radius incorrect. Okay, so the radius of Earth is on the equation sheet, and then they forgot to look at this part here with the altitude. Common mistake. They substituted the incorrect values. They forgot to change kilometres to metres. Alright, so this is from the SASTA board. Instead of using the gravitational constant, they actually used 9.8. Alright, they got their G's messed up. And also, people in an exam, they just didn't calculate them correctly. So typing it in, very important. Okay? Alright. And again, write out the equations, substitute the values. Oh, and this is one of the other major mistakes. When students do put a number here in the denominator and they square it, when they actually type it in their calculator, they forget the square. Because they've done the 10 to the power of 3, but they forget about, I've got to do another squared, another power of 2. That happens all the time, okay? So please make sure you're actually, when it's a squared under the denominator, put it in your calculator. Some of you are just going, what? That's what you normally do. Excellent, okay? But there's a lot of students who just forget that too. Alright. Electric field lines, okay? Zapping our food to actually kill all the bugs, etc. I never saw that question before. I haven't even heard of that scenario. Okay, that's used in food preparation. So, the key thing here, when you're drawing electric field lines, it's right angles to the surface. Oh, but I can't draw properly. Okay, put the right angle symbol on the surface there. Alright, so even if it doesn't look like a right angle, you've put it in, so therefore it must be. Okay? And some other students just did the one line last year. Put in at least 5 different field lines, okay, to show the patterns. Alright. Oh, and I made a mistake. What's missing off of that diagram? Direction, thank you. Okay, direction a positive charge would flow, so it should be I should have arrows there pointing to the heating plate. Naughty Gavini. Alright. Alright, as soon as I see a table, the first thing that's going to come to mind, there's going to be a graph. Okay? So we've got some primary coils, we've got some secondary coils, and we've actually got some voltages. Where we're told 1 was 150 turns, so this is where I need to know my ratio, because it hasn't told me the other turns. So even you don't even see the rest of the question, you can actually predict what the question's going to be. Oh, there's the graph, okay? Lo and behold, okay, the next question will be, where was it? Yeah, how many turns? All right, looking at that graph, that's a pretty straight line, isn't it? There's no scatter. The data collected is pretty good. All right, so therefore random errors or scatter is not much there. However, it doesn't go through 0, 0. It should, because if I don't have any power supplied, how am I going to transform? If I got 0 voltage or power in the first primary, I should be getting nothing out on the secondary, okay? So automatically in part B is a systematic error. Please note, see how that systematic error is worth 2 marks. So 1 mark for identifying systematic, justify it. Okay? A lot of students will forget that. Justify it. So you need to put in, if there's no current in the primary, then there shouldn't be any current in the secondary. You don't get energy for free. All right? What else did students stuff up with? Okay, so they actually worked out what the gradient was, even though they tell you that the gradient is actually there. So those students who would have sat there, done change in x over change in x over change in y would have actually done a whole pile of working out, no marks. Yep. Sorry. I can't hear. It's just random systematic. Okay? So it just says which one type of error. So what is it? Systematic. Why? Has to be in the context of this question. So if you start explaining what a systematic error is, no marks. All right? You need to explain it in the context that you have there. Second experiment, primary coil was removed, replaced with another primary coil that had a greater number of turns. So what happens to the voltages? You draw a line. There's nothing stopping you from actually going, oh, okay, so where's the slope? Is it going to be above? Is it going to go higher? Or is it going to go lower? Just plug in some numbers with higher turns, even though it hasn't given it to you. What do you get? Okay, so that's going to be my trend. Nothing wrong with doing that. All right, now, the biggest mistake that all the students did last year was that they drew the new line, okay, so the new line here actually going through 0, 0. The setup, they have asked this question several times before, and all the students stuff it up. Because the setup, the scenario, the practical, the technique hasn't changed, so therefore that systematic error will still be present. Okay? The only time you're going to get rid of that systematic error is if you use a different technique. So this question has come up from time to time, and it's caught students every time. So please be aware of that one. Okay? Question number 5. Particle goes through an electric field. All right, cool. It's pushed away from the positive, attracts to the negative, so therefore it must be a positive charge. It's worth 1 mark. I don't need to explain. Okay? Show that it took 5.02 times 10 power second, 10 power minus 7 seconds to travel. So that's just distance over time. All right, so that's a Year 8 science question there. And I believe that answer is missing out of your revision guide when I was going through it the other day. All right. So when you go to look at the solutions in the back there, that one's missing. Most students in the state got that one correct. Okay. Particle B doesn't get deflected as much. All right. So particle B enters the perpendicular, has the same initial velocity as particle A. Particle B moves along the path shown in the diagram below. Okay? So you're not told anything about, oh hang on, an identical particle. All right, entered the field. So its mass and charge ratio are the same. So the only thing that can happen is the electric field strength. Just like if you turned off gravity, all right, let's say you're on the moon, you reduced it, then the projectile motion path is going to be further. Same thing happening here. Electric fields are very similar. So path B has lower acceleration, experiences less force from the field. Acceleration is proportional to the electric field strength, and electric field strength is proportional to the voltage produced, or applied I should say. So the voltage is reduced. Why did I go for a very long explanation? Because I saw 3 marks there. All right. If I saw something like 1 mark, I'll just leave it. Okay, make it really brief. But there's 3 marks, so they actually want you to go through 3 steps to identify that relationship. Again, very important to actually look at the mark scheme when you're answering it. Okay? Sometimes they will not give you enough space. Don't worry about it. On your exam paper, you get a whole page of extra writing space. Write down the correct question number, and then you can say, tell the marker, oh, I ran out of room. All right, please turn to additional papers, and then they know where to look. Again, they're not going to go looking for it. You need to tell them where to look. If you've stuffed it up and you've drawn a line through it, or you've got extra details, tell them where to look. Don't risk it. All right. Cyclotrons. Helium mucus. Achoo. Heliums. Okay. Helium nucleus, automatically in the back of your head, you're thinking it's a particle that has 2 protons, 2 neutrons, and has a double positive charge. All right. So, state the direction of the uniform magnetic field within the Ds, and I didn't put the answer, but it's easy enough. Right hand rule, remember if you get slapped on the head, it's going to be an open hand, so that's the force. The direction is heading down, so the magnetic field lines are your fingers, so the magnetic field's coming out the page. All right? So, direction is going down on the right hand side there. The force, all right, is heading that way, so the fingers are your magnetic field. All right, magic fingers, magnetics. All right. Derive. So this is one of the derivations. All right, you need to know. People lost marks, probably 1 mark, because they didn't actually explain why they used those equations. All right, left-hand side, kinetic energy, half mv squared. So you're looking at the energy of a moving particle. All right, the other one, R equals momentum over QB. That is looking at the radius, okay, of a charged particle moving in a magnetic field. So just putting in those 2 small little explanatory comments will get you that extra mark. Substitute your values, bit of rearranging, okay? Again, write this out. Take a little video, keep watching it. All right? Just say, I'm going to watch this one every day for 3 weeks. All right? It will help you memorize them. Don't think you're going to work it out on the day. Again, stress levels, okay, you'll just automatically go blank. Oh, how did I do that again? I'm going to leave that, go on to another question. Hopefully I'll think of it then. Don't risk it, practice it, use the video technique that I showed you before. Alright, this one here. Again, students will always forget about that little 2 in there. Okay, use brackets, okay? And most of the students who stuffed up this one used the graphics calculator solver and didn't actually show the equations, the substitutions. So, bang, there was 2 marks disappeared off their paper. All right? If you feel yourself going to your graphics calculator to use the solver, don't. All right? Leave that for maths. And this is the other thing that they would have messed up. They would have forgotten double charge. However, last year they were actually quite nice to students. They actually reminded them that double 1.6 times 10 power minus 19 is that charge there. That was very nice of them. Normally they don't do that because they expect you to know what the charge on alpha particle is. This question here, looking at the emission spectra, if it goes down to the first shell, that's when you're going to get your ultraviolet, second shell, visible, third shell, infrared. Okay? A lot of students always forget that, and the most common mistake is that the energy goes to the third shell, not the other way around. Okay? I see that every year. So please do not make that mistake there. In fact, if I can actually pull that exam question out of my old revision guide because that one's asked every year. Next one, okay? So from N4 to N3, work out the electron volts because that diagram is only in electron volts. Every year there are students who forget to change electron volts into joules. Okay? So don't forget to times it by 1.6 times 10 power minus 19. Okay? It's a little bit like Avogadro's number. Some numbers you just memorize because you use them so many times. And then rearrange energy is equal to Planck's divided by the frequency. Rearrange that, substitute the value, work out your answers. Okay? A lot of students just left it as the wavelength and got the answer wrong because the question actually says frequency. So please don't forget to check what the question actually wants. So we have a charged particle in a magnetic field. So students who got the wrong answer started talking about centripetal motion, okay, and Newton's second law. So you really need to have used, right, what's happening with the change in radius, magnetic field and a charge. So always look at the context in which equations that you're actually applying. Again, students got this right, but because they did it using the graphic solver, they missed out all the working outs. Again, equations, substitute, rearrange, pop out an answer. Okay? And this one was actually looking at a charged particle. So ideally, you would want to be looking at some sort of number that's a multiple of the charge on an electron or proton. So don't forget to use a bit of common sense. Does this number make sense? All right. All right, this is the rocket question. Okay. So a lot of students actually forgot to actually state the conservation of momentum in their response. So just don't put down those equations, put down a little descriptor that uses them, that explains this particular scenario. So you're actually starting to notice a pattern where students are just losing marks here, there, and eventually they add up, okay? Remember, if you're chasing a merit at the moment, you need to be getting, even though they say, you know, it's not about grades, but behind the scene, unless you're getting a 14.8 out of 15, you're not going to get your merit. They don't like to say that, but that's what's actually happening. Okay, next one. So this spacecraft is actually travelling, and magnitude, so it doesn't actually want the direction, even though I put it there. Sometimes I'll say, you know, what is the velocity, or what's the force, etc. All right, must put in the magnitude and the direction. This one didn't require it, okay? So again, you know, Newton's third law, okay, so the weight, so therefore the force on the rocket must be the same as the weight because it's at a constant speed, so therefore the net force must be 0. So when they start putting in the little phrases like that, you need to have something in your response that actually addresses it. So look for those little hidden nasties that they chuck in. She question. Who loves doing she questions? What's wrong with you? I hate them as well, okay? I'm glad you enjoy them. Most of everyone doesn't like them, okay? You need to look at the scenario. And a lot of it you need to discuss. You're going to be making some inferences because not everyone knows about every sort of scientific discovery, exploration that's going on, okay? Unless you're reading about 6 different journals every week, all right? Like I do on a sad basis, okay? That's the response SASTA liked. It is a like, all right? Can I just really stress, do not explain, okay, CC dial, communication, collaboration, development, influence, application, and limitation. All right. If you start explaining those terms, you get 0 marks. Don't bother. Okay? Do not explain what the she stuff is. Talk about what is the collaboration and communication in this context. Okay? And if there isn't enough information, make an inference. One would expect this type. Right? And actually say that. So everything, if you read through that, none of that looks like the she statement that's in the handbook. All right? So all the students that lost mark did that without context. Okay? And notice there's 5 marks. So 1 mark would actually be at least some sort of logical assembly of the response with some good literacy. All right? So 4 marks on actually describing the she, 1 mark for linking it together and it actually makes sense. Oops. Satellites again. Okay, this comet's orbiting. So X is the point, not Y, because everything's an elliptical path, not a circular one. First law, it's an elliptical path. A lot of students stuffed this one up because they started talking about the comet. Okay? Talk about the actual point. All right? Because it says explain the answer to part A, which is actually talking about X. So please pay attention to the question as well. Diffraction grading, please put it on DEG mode. All right? I had a student who came out of the exam, I don't understand it, and I said to him, did you have your calculator on degrees mode? Oh, I left it on radians. Just before you even walk into the exam paper, just exam room, just make sure your calculator is on degrees mode, please. All right? And again, get your values, substitute, etc. Then there was actually determining the number of orders that you can actually view. That's a bit of a trick question because when you need to be looking at the angle being 90 degrees because you can't have any maxima displayed behind the actual light source. So that's a bit of a trick question, assume knowledge. So most of the mistakes is when students actually try to apply double slit as opposed to diffraction grading equations. So the two are different, okay? It says that determine the number of maxima, okay? So you can't get 3.6 maxima. You always have to do with a whole number. So again, that's looking at the logic in your answer. Does it make sense? And the other one that students always stuff up on, they go, oh yeah, you know, there's diffraction grading, you know, so there's 600 lines per millimetre. Standard unit length is actually in metres. So they forget that times by 1,000 in there. Just a silly mistake that you make during the exam because you're under stress and you forget things, okay? So please don't forget everything in metres. X-rays, What's the purpose of the target? All right, there's 2 marks there. There would have been students who said, oh, to reflect the light. Okay, no, all right. So don't forget to use braking radiation, and that's an example of using the proper physics terms rather than generic ones. That's where the marks are, using the correct literacy. Part B was a fairly straight one. Part C, again, students using graphics calculator, not showing the equations, substitution, and the working out. Maximum frequency, etc. Alright, this one here, A was the emission spectra, or in terms of intensity, from the X-ray source, whether it was tungsten or molybdenum, okay, because they're the 2 metals. You may get asked that question. Usually it'll be just tungsten. Line B shows the spectrum produced by the same X-ray, okay, after an adjustment was made. By default, students thought A was the adjustment line, because that one pops up in your workbook quite often. So again, don't forget to look at the question. All right, now the maximum frequency hasn't changed, so therefore it's not the voltage across the target, so you're just getting less electrons being emitted, so the filament's not getting hotter, so therefore less current going through the filament. And of course they discussed the wrong voltage, so when they talked about the voltage, they didn't talk about the one going across the filament to induce the current. Counterfeit coins. Again, this is a scenario I had never seen before, but it's going over a magnetic field. Coin is metal, so I'm looking at some sort of induction. Okay, use Lenz's law to explain the production of eddy currents into this coin. Alright, so that's just more or less saying if you want to do something to it, the response will be the equal and opposite. Alright, so when you look at part 2 there on the diagram, draw the direction of the eddy current being produced, magnetic field's coming out. To oppose that, the magnetic field must be going in. Okay, you have to do work, you have to use energy, and right hand rule, that's the current direction that would be in the metal disc. So don't forget about that opposites, okay? It's a bit like your younger brother or sister. You tell them to do something, they do the complete opposite. All right, and then using Lenz's law, again, students were pinged because they didn't use physics terms. So they didn't use things like magnetic field lines or flux, okay? Or motion, all right? So you need to use them big words. All right, this one here, where is the energy loss? A lot of students forgot, conservation of energy. Again, that's a Year 8 science thing. You can't get something for nothing. So the energy is actually reduced, conservation of energy. I would say that about half the students would have lost 1 mark from that question because they didn't say where the energy came from, conservation of energy. Alright, I've got another graph coming up. I have to draw it, not draw it. State why 3 measurements were taken, so you can actually reduce random errors. And if you look at those numbers, the genuine coin is fairly consistent, and the counterfeit coin is actually all over the place, which makes sense because when they make counterfeit coins, they're not, the metals that they use are not homogeneous with the whole set, so they vary. So that's the question there. Genuine coin has more precise values, less scatter than the fake, than the non-consistent mix. All right? So here they actually confuse precision with scatter. So again, understanding between systematic and random errors and all the sort of observations you would get in a graph. All right, looking at forces on a charge, equilateral triangle, love them. okay? Because you're not going to have to use your calculator too much. You're not going to be using sine, cos or tan because they're not allowed to, all right? There was probably over 15 years ago, they made a ruling that you can't use the general equation for working out triangles that are not right angles. But with a 60-degree one, okay, you can get away with it because you know it's all going to return to the same spot. All right, F equals the charge constant, Q1, Q2 over R squared. Again, students will always forget that little power there, especially if there's some sort of 10 to the power minus 3 or minus 4 or something else in there. They didn't use that equation correctly. State the magnitude of the force acting on Q1, Q2 and Q3 is going to be equal and opposite. So Y, Newton's third law, okay? Vector diagrams, students lost marks because the diagram was too small, drawn badly, okay? So please make sure you use the available space to do it, okay? So with your vector diagrams, start, finish, and then the resultant vector is from the start to the finish, all right? Or head, tail, start, finish. So automatically you know when you get a 60-degree one, it's going to finish nicely. Unless, so the 90-degree ones are okay, you use a bit of trig, 60 degrees, fairly straightforward, but then there's also ones where you are given the vectors on graph paper. You still don't use trig. You actually use rise, run, you count the squares. So if you look at some of the older ones, exams, you'll see those examples, have a go at those. All right, interference pattern, double slits. Why they're dark spots? Because it's destructive interference. So they described it, but they didn't explain. Okay, why is it destructive? Because there's actually half wavelengths. Optical path difference is a multiple of a half wavelength. So again, don't forget that terminology in those questions. All right, write out the equation. First bit is an average, substitute, and calculate. Students forgot to convert the units. All right, meters, millimeters, centimeters, etc. A careless mistake, but a little bit here and a little bit there. Okay, lose 2 marks, there's 1% of your exam, because it's usually out of 200. All right, work functions. There's only 2 more questions to go for this exam paper. Again, work function is HF, so you're actually trying to get that electron out of the shells with 0 kinetic energy. And if there's any energy left, then that will be transformed into kinetic. So a lot of students actually did not remember that, and they actually substituted the wrong values in order to work out the kinetic energy. All right, so you needed the energy of the photon that was left, that was provided, how much work was taken to eject the thing in the first place, and then the leftover is going to be kinetic energy. Also, students forgetting electron volts into joules. All right, times it by 1.6 times 10 to the power 19. Didn't like this question. It's a little bit ambiguous, and who remembers what Einstein did? He did lots of things, etc. And I'm pretty sure he didn't do this one alone. So just remember that the energy shells are actually quantized, okay? A lot of students didn't use the correct physics terminology. All right, so usually when they're not understanding it, so make sure you use shells, orbitals, photon energy, threshold, all those descriptive physics terms, all right? Because marks will be allocated for the exam markers. They'll be given a sheet with suitable answers, and they'll be looking for those key words. This one was a bit of a bummer, stuffed up a lot of students last year. Relativity, instead of actually looking at relativity in terms of time, length or velocity alterations, it was actually looking at the Lorentz factor itself. So, and that threw a lot of students. Okay? So it's good that you know about this one now, because that's the fourth one that you can be asked. You know, velocity, time, length, and also playing around with the Lorentz. So write down the equation, rearrange it, because it was showing that the speed, so you had to rearrange the Lorentz factor, so velocity was on the left-hand side, and then substitute in, and it told you the answer, so you knew what you were looking for, but that didn't help students at all. Okay? So, unlikely to be asked this year, but please know that's the fourth variation on the relativity one. Students forgot what FM was. It's not a radio station, it's a femtometer. Okay? On your equation sheet, you're actually given those on the second page, bottom left-hand corner. So that threw a lot of students, because they're going, what the hell is 0.1 FM? Okay, is that fresh as 92.7? So, okay. Write out the equations, substitute the values, and then you can leave it as, in this case, instead of expanding it, you could left the symbol as femtometers. So always remember to put the units. 18, I really hated this question last year, because it was a dumb question. Complete the chart here, okay? If you haven't started standard model, you're going to be starting it hopefully very soon, or on the first week back of your holidays. Muons and electrons, okay? Muons are going over to here, that's your reactant. There's your products, if you want to think of it in terms of chemistry. So you're actually looking at this charge here. So the charge on the left-hand side has to balance the charge on the right-hand side. For some reason, students went across the columns, so they got it wrong, okay? Or they confused the signs. So if it's normal matter, don't write 1, write +1, okay? So the normal matter is +1. That's an anti-electron neutrino, so therefore it's -1. Because they both are part of the electron family, they get their own little column. That cancels out to 0. And muon, normal matter there, and a neutrino muon, so therefore they belong in the same column. So that's on the left-hand side, that's on the right-hand side, everything's balanced. So that's under your rules that you need to remember. Which then makes the next question silly, in my opinion. I'm pretty sure the SASTA board would tell me off. Alright, so not a good question, has contradictions, but by definition, all of those numbers, you had to learn those rules, okay? Now this question actually asks you to justify it, okay? But then when you had to justify it, you had to know the numbers in the first place, so it was a weird question, alright? So you can actually justify this one here. So if that's +1, none of these are muons, so therefore that is a muon particle, so it must also be equal to +1 for it to remain balanced. Then this is the contradiction here. How do you work that one out? You can't, other than knowing that an electron is +1, so therefore its antineutrino must be -1. But you can't do that one in the first place without actually remembering the rules for that one. Oh well. But yeah, students did lose marks for not remembering the balancing of the numbers. Okay. So that's last year's exam paper. All right, I'm just going to have a drink for a second. All right, she. If you haven't heard about it, CC dial. If you want a little quick phrase to actually remember all of them. What I've actually highlighted here are the key words that you're going to be looking at or looking for in your responses. So with communication collaboration, you definitely want to see some sort of communication. So they're speaking with each other, they're networking, etc. They're actually doing reviews, they're verifying, so they're getting other people to check on it, okay? And different agencies. So then you look at private companies and public companies. It's just like when the CSIRO actually deals with, with the, let's say, the vaccine production. All right? So you actually have public and private interests, and you'll see that with universities working with government bodies, etc. When you're looking at development, okay, you're looking at models of theories. As soon as you see cross-disciplinary, so let's say there's some physics stuff that's actually looking at, I think the 2018 one was looking at earthquakes. So the Geological Society was actually working with the physics sensing department. So that's actually development. All right, cross-curricular. New technologies, collecting, analysing, getting new data. Okay, that's your data logging. So that's all your development. So those are the key words that you're looking for. And again, if you write these things down in your SHE response, 0 marks. But they're the ones that you're looking for. Influence, so other areas, okay? So that's when you're looking at science, not working with other science bodies, all right? So scientists working with particular indigenous cultures, okay, to actually improve. Or science working with agriculture, people trying to improve farming techniques, etc., if you're doing some stuff there. Application and limitation, so you're looking at solutions, predictions, development, okay, and then you're actually doing risk assessment. What in the future, how can this go bad? And a classic one is, especially with the informs public debate, is whether South Australia should produce electricity through nuclear power. All right. So again, requires monitoring, assessment, evaluation of risk, which they all did. They had public forums, which was part of the development. So again, monitoring to see, you don't know the future, so you've got to make sure you track it. Sometimes they'll actually put that application and limitation in because they'll put a scenario and then they'll say what needs to be done into the future to make sure it's safe. So that's when you start looking at application limitation. So you might want to put some sensors in and then talk about in the river streams, or you actually put the sensors 1 kilometre under the ground or something else like that, just so it's actually in context. All right, final stretch, handwriting. If you can't read it, it gets no marks. Okay? So hats off to that student who wrote true, false there. There is no half marks. Your teachers would have already been practicing that with you so far. You're not penalised for the same mistake twice, but again, it's not good, all right? Because then the marker might go, well, this kid doesn't understand it, etc. Spelling is not penalised unless the answer becomes ambiguous, right? Sometimes they will penalise you on the spelling because there's a slight confusion. There's only a couple of words that they really get fussy about, but yeah, try and make it look correct. Also look at the marks, the awarded to the question. Do I have too little or too much information? I had a student once write, almost half a page for a 1 mark answer. Why? Okay. And that's it. So, best wishes.